Hello class, this is lesson 2.3 on composite functions. So I defined what a composite function is here on this page. First we let f and g be functions. Say they are functions of x. Okay. Now the composite function f of g, it's read f of g, and we use the symbol f circle g of x, is simply defined in the following way. First we just take g of x and we plug it into f of x. Alright, so we take g and we plug it into f. That's what we mean here. So f of g is when you take g and plug it into f. The domain of f of g is the x values in the domain of g, and we add an extra condition that the outputs of g have to be in the domain of f. Okay, so we could draw a picture, although I don't think the picture is too helpful. It's better if we just do some examples, but let's say this is the domain of g, so we have some x value. And since it's in the domain of g, we are allowed to plug it into g. And when you plug it into g, it will spit out output. So this will be the range of g. Alright, so what this figure means is if we plug this number into g, it will spit out this number. And these blobs represent all of the such numbers. So everything in this blob is the domain of g. We could plug something in, and it will spit out another number, right? G is sort of like a map. It maps this blob onto this blob. Okay, but now what if we want to plug the outputs of g into another function? So we take this value, g of x, and we plug that value into another function called f, right? And then the outputs of that we can represent by this blob. So it will spit out a value f when we plugged in g of x. So what we could have done is just skipped the middleman here and plugged the original x into the composite function f of g of x. Okay, so that's sort of the picture here. Let's now just look at some examples. So we could start easy. I will color code this as well. So f of x equal, I'll do this in red. Let f of x equal x squared, and then here in green we will say g of x is x plus 2. Find f of g of x and its domain. Okay? So by definition, f of g of x just means we take f and we plug into it g. Right, so f is the outer function, g is the inner function. Now g was given by the formula x plus 2, so we're really plugging x plus 2 in the f function. And recall, f is this x squared, right? So whatever we plug into f, we just simply square it. So if we're plugging this into f, then we just square that as well. Alright, so let me repeat that. Whatever we plug into f, it just ends up getting squared. So the answer is x plus 2 squared. If we want to multiply that out, we can, although it might not look as pretty. We get x squared plus 4x plus 4. Okay, now for the domain, we have to be careful. We can't just look at the domain of our results, although that will sometimes give you the right answer by coincidence. When you find the domain, you have to do it by definition. Find the x's in the domain of G, such that G of x is in the domain of f. Now sometimes when you do that procedure, it would be the same as just looking at this formula's domain. In this case it would be the same, but we'll see some examples shortly when we can't just look at the domain of the resulting formula. Okay, so the domain of the inner function g is all numbers. The domain of the outer function is also all numbers. So this is an easy example. Right, so the domain of f of g will also be all real numbers because we're allowed to plug anything into G, that's easy, and then anything in the output of G is allowed to be plugged into F because the domain of F is really nice, it's all numbers. So this was an easy example for the domain. We'll see some more tricky examples shortly. Let's maybe look at one right now. Let f of x be x squared, g of x be the square root of x. Find f of g of x and its domain. Okay, so f of g x just means we have f and we plug the formula g inside. Right. Now if you recall, g is equal to square root of x, so we're just plugging the square root of x inside of the formula f. Now f is just the function that squares whatever you plug into it. So we get this. Okay, now notice how the square root and the square cancel. And we're left with x. Alright, so f of g of x equals x. Now let's consider the domain. And as I said earlier, we can't just look at the domain of this formula, because with the domain of this formula, without any context, if we don't ignore all this stuff above, the domain of this would be all real numbers, but that's not how the domain is defined. Remember, define the domain like this. All the numbers in the inner function's domain such that the output of the inner function is in the domain of the outer function. Okay, so let's take this step by step. We take the domain of the inner function. Okay, the domain of g is the numbers 0 to infinity. Right, we're only allowed to plug in numbers greater than or equal to 0 into this function. The domain of the outer function f is all numbers. Okay, so let me write down the definition of domain of f of g. It is the x values in the domain of g such that g of x is in the domain of f. right? So that's sort of a wordy way of writing it. Let's see if we can clean this up. Okay, so we want x to be in here, that's our first restriction, and then we want g of x, or the square root of x, to be in minus infinity through infinity. Right, or we want the range of the square root of the range of g to be in the domain of f. Okay, so that will just be number 0 to infinity. Let me draw the graph of square root of x for you. It looks sort of like this. The graph of g of x. So as you see, we plug in numbers greater than or equal to 0, and it will always spit out numbers here, which happen to be in the domain of f, so that's good to go. And our answer is thus 0 to infinity. Right, so even though out of context you could plug anything into the formula x, but we have an added restriction here because we were dealing with a square root. Now even though the square root went away, we cannot ignore the domain of the inner function. Okay, so we have to be careful about domains. Okay, let's look at another example here. F of x 2 over x plus 1, g of x be x minus 2. Find f of g of 3. Let's do g of f of 4. Okay, so I haven't told you what these symbols mean yet, and I'll explain that now. It means the following. F of g of 3 means we plug g of 3 into f, right? So it means you plug 3 into g, then plug the output. The output is g of 3. Plug that into f. Okay, so you could do it all at once, or you could do it step by step. Let's just do it step by step here. G of 3 is 3 minus 2, which equals 1. So then we take this 1 and we plug it into f. So now f of 1 equals 2 over 1 plus 1. So 2 over 2, 1. And therefore, f of g of 3 equals 1. Another way you could have done it is first you could have found f of g of x and then just plugged in the number 3 for x. So let's do that just to verify it's the same thing. So if we did f of g of x, and we just take this formula for g and we plug it into the f formula. So the formula, the outer formula was 2 over an input plus 1, right? That's our outer function. Now we're going to plug this inner function into the outer function. The inner function is x minus 2. So f of g of x is 2 over x minus 2 plus 1. Right, and then if we plugged a 3 into here, if we did 3 into here, we would get 2 over 3 minus 1, 2 over 2, 1. So we do get the same answer. Okay, the next question was g of f of 4. So that means you plug a 4 into f, and we take the result and plug that result into g. Okay, so next we want to find the g of f of 4. Alright, so first we can look at f of 4. That would be 2 over 4 plus 1, 2 over 5. So now we look at g of 2 over 5. And that would just be 2 over 5 minus 2. So if we multiply 5 to the top and bottom of the number 2, we get 10 over 5. So now combining these two fractions, we have negative 8 over 5. Let me ask one final question. What is the domain of f of g? Right, well, domain here of g was all real numbers. Right, remember g was just x minus 2. F was 2 over x minus 1. Right. Okay, so the domain of f is minus infinity to 1, 1 off to infinity. Right, or in other words, we are not allowed to plug in a 1 into the formula for f. Oh, sorry, that was a plus 1, not a minus 1. Excuse me. Let me correct that. We are not allowed to plug in a negative 1 into f, because if we plug a negative 1 into here, we would have 0 on the bottom. We can't have 0 on the bottom. So the domain of f is all the numbers, but we have to skip over the number negative 1. That's not allowed. Okay, so the domain f of g is what? It's all the numbers in here such that the output of g will be in here. Okay, let me write that down. All x in the domain of g such that g of x, or x minus 2, is in this interval here. Okay? Okay, so we want x minus 2 to either be less than negative 1, or we want x minus 2 to be greater than negative 1. Because if x minus 2 is less than negative 1, it will be in here, which is fine. If x minus 2 is greater than negative 1, it will be in here, which is fine. Okay, so now we just solve these two inequalities. Right, so in other words, we want x to be less than, well, we could add the 2 to both sides of this. We want x to be less than 1, or we want x to be greater than 1, right? So if we draw a number line here, here's the number 1. It could be less than 1, greater than 1. It cannot equal 1. So the domain f of g infinity to 1, 1 to infinity. Okay. So again, we learned how to plug in numbers to composite functions, learned how to find domains of composite functions, and just how to think about composite functions. So that will be all for today's lesson. Thank you for watching.